Section 3.5, we're focused on the formula y equals mx plus b. Y equals mx plus b, where m is the slope of a line and b is the y-intercept. So when we're asked to look at these equations of lines and figure out what the slope and intercept are, we're going to be looking in front of the x term for m the slope. We're going to be looking after the x term for b the intercept. For this first one, part A, I see that in front of the x term is a 5, so I'm going to pull that out as the slope, m equals 5. I see after the x term is a negative 3, so I'm going to put that in the y-coordinate of the y-intercept. The x-coordinate is always 0. So this equation of a line has a slope 5 and a y-intercept of 0, negative 3. If I do the same thing for this line, little trickier here, what's in front of the x, even though it's a negative sign only, there's an understood negative 1 there. Whenever there isn't a number in front of the x, it's understood to be 1. The same way it's understood to have an exponent of 1 here because it's to the first power. So even though the 1 wasn't there, this slope should be negative 1. After the x term is a plus 1, which means 1 goes here in the y-intercept. Always 0 is the x-coordinate. So this line has slope negative 1, y-intercept 0, 1. The third one here starts out as x over 4 minus a half. Again, whenever I see that x, it's an understood 1x, and really I can pull that fraction out front as the slope. So this 1 over 4 can really be written as 1 over 4 times x, meaning that the slope is 1/4. What comes after the x, the sign and the fraction, negative 1/2, is my y-intercept. Always the x value of the y-intercept is 0. So this line has slope 1/4, y-intercept 0, negative 1/2. For the pair of equations, determine parallel, perpendicular, or neither. When we're doing this, all we care about is the slopes. So we're going to be looking in front of the x term to see what the numbers are. Our choices are either they're the exact same number, in which case we say parallel. They're negative reciprocals of each other, in which case we say perpendicular. Or they have neither of those relationships, in which case we say neither. When I look at the first one, this line in front of the x term has m equals 2. In front of this x term is m equals negative 1/2. Looking at them, I know that they're not the same, so I can rule out parallel, but I need to figure out if they're perpendicular or neither. If I want to write this slope that's a whole number as a fraction, I always write a whole number over 1. That way you might be able to see that what starts out as 2 over 1 becomes 1 over 2 when I flip it. 1's positive, 1's negative, so yes, these are negative reciprocals of each other. The other way I could figure that out is I could have taken this slope of 2, multiplied it by this slope of negative 1/2. If I put it in my calculator, press enter, and the answer is negative 1, then they are perpendicular because they're negative reciprocals. So I'm going to write here, perpendicular. When I look at part B, the first one has a slope in front of the x term of 2, m equals 2. The second one has a slope of 3, m equals 3. These are not the same number. If I multiplied them, I get 6, not negative 1, because they're not negative reciprocals of each other. These don't have either relationship. So here I would write neither. The third group here, or the third problem, I have an understood 1 in front of this x and understood 1 in front of this x. It doesn't matter that this doesn't have an intercept, I still can pull out the slopes. The first slope is m equals 1, the second slope is m equals 1. Since they both have the same slopes, they're parallel lines. So I'd write here, parallel. Last thing I'm asking you to do within this classwork is to write the equation of the line with a given slope and y-intercept, then use it to graph. So basically in the y equals mx plus b equation, y is going to stay as a variable, x is going to stay as a variable. What I'm going to write in is whatever I'm given as the slope, I'm going to write in front of the x. Whatever I'm given as the second coordinate of the y-intercept, I'm going to write in after the x. So this one with slope of negative 2 and y-intercept of 0, 1 can be written as negative 2x plus 1. If I'm doing it for this second problem, the x comes in, I write the slope in front of it, 3/4. I write the y-intercept after it, -3. This also tells us to graph. I really should have put my marks on beforehand. Sorry, I forgot to do that. I'm going to do it quickly, so they might be a little sloppy. Apologies. 5, 6, 7, 8. Let me do them over here. When I start, I want to put in the y-intercept, 0, 1. 0, 1 would be right here. Always the y-intercept is going to be on this up and down axis, and you're going to count up or down based on whether this is a positive or negative number. From there, I need to use the slope of -2, really written as a fraction, -2/1. That tells me from this point, I'm going to go down 2, right 1, down 2, right 1. So the general look of this line should be about like that. Again, I recommend doing 2 points. Make sure they're on the same line. That way, if you rise over run and something goes wrong, you'll see, well, wait, these 3 points don't really have a straight line between them, and you can go back and see if maybe you measured 1 too many or 1 too few in one of the directions. When I go to do the second, 0, -3, I start on this up and down axis. From the 0 point, I go down 3, 1, 2, 3, and I put a point there at 0, -3. This 3/4 slope, 3/4, tells me that I go up 1, 2, 3 over 1, 2, 3, 4. I can put a point there if I do it again. Up 1, 2, 3 over 1, 2, 3, 4. About there. If I connect these points into a line, I can see that the line looks about like that.